So we've had enough of epithelial tissue probably. We're ready to go with the connective tissue. Connective tissue has the following functions and roles in the human body. It provides certainly for organ support, and also we'll see is critical to movement of the body. We will store lots of energy within this. This has to do with the role of adipose tissue in the storage of triglycerides. It functions to cushion. It will be involved, connective tissue will be involved in transport, and when you see the specific types or structures that are involved or classified as connective tissue, you'll see why we include this and incorporate this in the functions. There are abundant numbers of white blood cells in the role of the immune system within connective tissue, and then connective tissue displays an abundance of extracellular matrix. What the hell is that? Well, first look at the words. Extracellular. So this is structures that exist outside the cells and provide some type of framework for their positioning in the human body. So the extracellular matrix is produced by specific cell types in connective tissue. And these cell types will have specific suffixes attached to them depending on their role in the connective tissue. And so the first of these cell types are the blast. And the blast make the matrix. They manufacture the extracellular matrix. And we'll define what exactly the matrix is here really quickly. So if you're a blast cell, you're producing it. If you are a cyte, then you used to be a blast cell, but you now have transitioned into the role of maintenance of the matrix. And lastly, one of the types of connective tissue, bone, has a third type of cell called the clast. And clast break down the matrix. So what the heck is this matrix? Well, first off, the matrix is composed of a substantial amount of protein. And there are 3 proteins within the matrix. There's collagen, the most abundant protein probably in the human body. There's elastin, and there's reticular protein fibers. So these are the 3 types of protein fibers that you may or may not find in the extracellular matrix. It can have all 3, it can have 2 of the 3, or it can just be one of those 3, but one of them will be involved in the extracellular matrix. Now, collagen fibers, we already pointed out, are the most common in the body. They typically are very long, straight, very powerful, and strong fibers. Okay. Reticular fibers are more or less interwoven, like netting, if you will. And this interwoven feature really supplies the function of reticular fibers. We're going to find them as filters or as surroundings of particular tissues that act as protection. Finally, we have the elastin fibers or elastic fibers, and they contain the elastin protein. And when you think of elastin protein, you should think of stretchability and the capability of tissues to resume their shape once they've been deformed. So the third, or the other component of extracellular matrix that is so critical and is truly the hallmark of connective tissue is the ground substance. And the role of this ground substance is that its consistency, whether it's more fluid or mucousy or becoming more gel-like and then rubbery and then very, very hardened, that consistency determines the role of that particular connective tissue. The ground substance then is what fills the spaces. Certainly we'll have water in it, we'll have proteins in it, we'll have other molecules we're about to talk about here. It is largely colorless and very viscous. What's viscous? Remember? So that's thick. How thick is it? So it's a pretty thick substance, but again, the thickness determines the role of the connective tissue and its function. There are, of course, many other molecules in here, these so-called non-fibrous molecules. Chondroitin You'll know a lot more about it, especially if and when you have joint problems. So you may have heard of the supplements chondroitin and glucosamine. So chondroitin's found in ground substance. A component called hyaluronic acid is found there. It's a polysaccharide. All right, so this is going to be a means of supplying energy and so forth. And then a class of molecules called proteoglycans. These are the ones that determine the consistency of water. And finally, there are many adhesive molecules that provide some type of consistency for the ground substance. We should briefly cover the different types of connective tissue because this is what we'll be doing next video. We have loose connective tissue types and dense connective tissue types. Together in the book, they are classified as fibrous connective tissue. So these two connective tissue types are classified as fibrous. Then we'll talk about adipose connective tissue. In many books, it's not considered a separate type of connective tissue, but your book does consider it as one, so we will specifically mention it. Cartilage, bone, and blood. And you start to think, aha, blood. That's where we get the transport function.